next to me is Jacek Kunicki, who is going to talk about gorillas and Swiss cheese, what emergency medicine can teach you about software development. And Jacek is a senior software engineer at Software Mill, so be ready with your questions after the presentation. If you have any, let's do it. And a round of applause for Jacek. Off you go. Thanks.
Thank you. So it was a true challenge to find a suitable picture for this first slide here. I wasn't able to do it myself, so I asked our marketing geek for help, and we tried a bit of stuff. We started with something obvious, then we even tried emojis, but eventually we find this gorilla made of cheese. And when we found this one, we knew that this is going to be the main picture for the slide. So hi everyone who are here both physically and remotely. Welcome to this session about some analogies between emergency medicine and software development. I'm Jacek Kunicki. I'm a software engineer at Software Mill. We're a Scala and Java consultancy based all around Poland. There are actually two specific things about our company. The first one is that we've been remote from day one, so we don't have an office at all. We've only been working remotely, and it's 12 years now. And also our company is fully transparent when it comes both to decision making and to financial transparency. So if you'd like to hear more about how this works or how it doesn't work, feel free to catch me afterwards. So I'm Jacek, and I usually avoid the about me slides, but this presentation is special because, as you saw in the title slide, there will be some stuff from the medical field. So I need to make a short disclaimer before we start. I'm not a paramedic, I have no medical education, but still all the medical stuff that I'm going to show here is evidence-based. So this is not something I have invented, this is actual medicine and to the best of the current medical knowledge. So if I wasn't a software engineer, I would probably become a doctor, but that didn't happen. Still a couple of years ago, I started my adventure with first aid beyond the basics. I took a couple of courses. I started reading books, movies, watching movies. And at some point, especially while reading one specific book, I discovered that many trends that we can see in the modern emergency medicine are very similar to what we have in the software development area. And this is related mostly to something that we call software craftsmanship. So let's see what I've discovered. To start, we'll come back to a bit to the past, to the times of the Second World War, and then by that time, on some islands on the Pacific, there were soldiers from different countries who were deployed there because they took part in the war. And when they were there were aircrafts that were bringing them a lot of cargo, like for example, clothing, weapons, food, stuff like that. So on those islands, there were also the original inhabitants of those islands who were not that technologically advanced as the troops that were there. And they were observing that there are like things flying in the air, coming and bringing food. So they didn't know about such technology. So their thoughts were that it must be some divine force. And something interesting and quite surprising happened when the troops left the islands after the Second World War. Because the original inhabitants thought that if they start imitating the behaviors of the soldiers, probably they may be able to attract the divine forces that were bringing food, clothes and stuff, and then the airplanes would come back and bring the cargo again. So what they started doing was building some mock-ups of airplanes, of airport infrastructure, like very primitive control towers, for example. Because they thought that if they do the same thing as the soldiers did, the cargo or the divine force is going to come back again. Of course, it didn't happen, but there is a phenomenon named after this behavior where you blindly follow the behavior of other people without actually truly understanding what you are doing. And this is called cargo cult. So this is an emergency blanket. If you have your first aid kit, you have something like this probably inside it. This is used to protect casualties from losing their heat. So, for example, if you go on a street and you see someone lying on the street and it's cold, you take your first aid kit, you take this emergency blanket, you cover the person, and you're done. They are protected, right? Well, not really. If you approach this situation with a thermographic camera and see what it looks like, You will see an image similar to this one, and the brighter areas here indicate the warmer areas. So this person is rolled on their side, and you can see how much heat is escaping through their back, which was not covered, and this is all conducted to the ground. So if you cover someone lying on the street, it's actually not protecting them really, so because a lot of the heat is escaping. But still, although we know that like those are the facts, there are like publications about that show that this actually happens. Still, many people, even professional paramedic teams, are doing this like that. So they just feel safe by covering the person with the emergency blanket, and they are done. Why? Well, because this is the cargo cult. They've always been doing this like that. They've been told to do it like that, so they are doing this. So you might ask yourself how this is related to software engineering. Well, think about Spring framework, for example, or if you are coming not from the Java world, of any other framework that is doing dependency injection for you, because this is what this annotation in Spring actually does. So this is actually a framework that is calling constructors for you. And is this really necessary? Like, is this really worth the cost of a framework that brings additional complexity just to create new instance of your class, for example? In the Spring framework, there is a separate instance of another class called a proxy created for every object that you are using in the dependency injection mechanism. Is there anything inherently wrong about just calling new manually and doing the dependency management by yourself? How about if you bring some more layers of abstraction? Are they actually solving your problems, or maybe they are introducing some new problems that you even don't know about at the beginning and that you would need to solve in the future? Think of Java Persistence API, or again, if you are not from the Java world, this is of any object relational mapping mechanism like Hibernate or anything like that. So ask yourself, when was the last time when you wrote a plain SQL query? And is there actually anything wrong with writing a plain SQL query? If the task of your data access layer is to fetch a user or the user's name by ID, do you really need the entire object relational mapping mechanism for that? All the annotations, all the problems that such frameworks introduce? Perhaps you have also encountered a situation where you have been writing the object relational mapping code and it has become too complex, you actually lost control of what's happening, and maybe at some point you even had a thought that maybe if you just wrote it in plain SQL, it would be easier. Here's another example. This is the Scrum process that you are probably familiar with. And my doubt is whether the Scrum process, like this full Scrum, is actually solving all your problems, or maybe it's introducing new ones. So I would argue that that there are simpler approaches. There are approaches like called like Kanban, for example, or Scrum-Ban, which is a mix of Scrum and Kanban, so a Scrum simplified. Or there are even approaches generally called Scrum-But, which is Scrum but with some things removed. And since Scrum tends to be an agile approach, I would argue that actually doing Scrum 100% by the book is, in most of the cases, not the perfect solution. I've been once working for a client who was doing Scrum exactly by the book, and it really has introduced more problems than it solved, because we were focused too much on the process instead of the actual work that we are doing. So if you're agile, I think this really conflicts with going 100% by the book, just because everyone is doing that. Like, everyone is using Scrum, so why don't we? How about microservices? Like, this is quite an overhyped, or at least hyped approach to building applications these days. Microservices have their pros, of course, but they are not applicable to all the situations. So we should probably, when we decide to use microservices or not, we should consider what problem we are solving. And at another company and another client that we are working for, the company chose microservices only because the head of marketing heard that this is like a cool technology, and they said, hey, let's use microservices. And it took us half a year to convince them that actually this is not a good approach, and their problem was a perfect use case for a distributed monolith, which is like quite a bit similar to microservices, but not really. It's quite a different approach that doesn't have all those problems that microservices can introduce. Now, I'm not saying that you should avoid using frameworks at all costs, frameworks like the automated dependency injection or object relational mapping. What I'm saying is that you should ask questions. So whenever you decide to use a technology, you should actually ask whether it is solving your problems, and you should answer honestly. Because it's perfectly fine if you are actually solving your problem and not introducing new ones, it's okay to use the frameworks. They are there to help you. But you should avoid a situation where you use a framework like Spring, for example, just because everyone else does. So this is not a good argument. What we see here is a medical procedure called intubation. And intubation is used when there is a risk that the airways of your casualty, there is a risk that they become obstructed and the air won't be able to get to the lungs. So what intubation means is putting a plastic tube inside your throat so that it goes to the lungs, and then you can ventilate the person, and the air can get to the lungs and they can breathe, even though the airways are obstructed. This is a tricky procedure because, like, if you put a tube in your mouth, you can either go to the lungs or you can go to the stomach. And when you go to the stomach, this doesn't really work because your main goal was providing oxygen to the lungs and not to the stomach. So this is actually a complication. Now there is a very simple way of measuring whether this procedure, the intubation, was successful or not. And this is by measuring the amount of carbon dioxide that the person is breathing out. So this is the EtCO2 that you can see in the warning message at the top and on the graph at the very bottom. And actually, this is a very accurate measurement that tells you whether the tube was put correctly in the lungs or in the stomach. But still, there are many paramedic teams who, instead of using this proven technique, they are using some different approaches to verify. And we can almost say that, well, they are not guessing, but they are using approaches that are far less reliable. So you have a situation where you have a way to prove that something works, but instead you are guessing whether it works or not. Does it sound familiar? Let's say you have deployed your application to production, and now you look at the logs of your application, and, well, it has started. There are no errors, so you assume that this is working. But are you sure that this is working? First of all, does the sole fact that there are no errors mean that the application is working? Maybe your error logging is broken, maybe the entire logging mechanism is broken and you just don't see it. So actually it would be better to have a way to prove that the application is actually doing what it should be doing. So you have read about metrics, and you put some metrics library, you introduce metrics to your deployments. And for example, you get a graph like that where you have the usage of memory and the CPU. Well, this tells you something, but does it already tell you anything about whether the application works or not? Like whether it fulfills its business requirements? I would say not, because those are strictly technical metrics and they don't tell you anything about the business use cases, whether they are served or not by the application. So you can imagine an even more complicated dashboard. This is a dashboard for akka, the actor framework. But this is still very technical. So what you can see here is a set of metrics, but they are strictly related to how the actor system works, how the distributed message processing under the hood works. But although it's quite complicated, and like when you look at it at a first glance, it may see and look like a nice thing, but it's really not useful because it still doesn't tell you anything about the business. So you can imagine an even more complicated one, and this actually has some more technical, also some technical stuff. But here, if we zoom in, it actually introduces some things related to the business. So you can see, for example, some latencies and errors by a particular REST endpoint in your application. You can see what's the amount of errors in given endpoints and how the application behaves. So this tells you much more than just a pure log file in which you would either see errors or not. This actually proves that the application is doing what it should be doing, provided that you design your metrics correctly, which is like another story. So, of course, the more experience you have, the more trustworthy the apps you are writing are. And of course, you are good developers, there is no doubt to that. But you should have a way to prove it. So you should have some kind of metrics that prove that the software that you have written is actually working correctly, and it is doing its job. So in this section, I'm going to show you a short movie. There is going to be no sound, just a video here. Please read the instructions. Please watch it. So if you have seen the gorilla, it's good for you. But in this experiment, well, the gorilla was there indeed. But when this experiment was performed, it turned out that 50% of the people who watched this movie for the first time, of course, didn't notice the gorilla. Here's another example. This is a computer tomography or CT scan of human lungs. And there was another experiment that was performed on a group of radiologists who were whose daily job is to look at images like that to find signs of cancer in the lungs. So they were given a set of pictures like that and they were asked to decide whether there are signs of cancer here or not. And if you look at this closer, you might or might not notice the gorilla in the upper right corner there. And in this experiment, it turned out that 83%, didn't notice that the gorilla was there. So what's the problem actually? Like the gorilla is there and they were trained to look at those pictures. So the thing is that if you focus too much on one thing, like on a very specific task, you start thinking selectively. And you can say that you become partially blind, or to call it more scientifically, you are suffering from something called tunnel vision. So you have these blinders on your eyes and you don't see anything around you. And this can have some serious consequences in emergency medicine, for example. If you imagine a casualty that has a number of injuries, some of them might look really seriously because, for example, there is a lot of blood, but they might not be life-threatening, actually. And if you get distracted by such a seriously looking injury, like by this huge amount of blood somewhere, you may actually miss an injury that is life-threatening, but it's not that obvious. It might be hidden somewhere, for example. If you try to translate it to software development, for example, sometimes it happened to me a lot of times. When I was debugging my code, I was like following only a single path. So I assumed that the problem must lie somewhere here. And I focused on a single flow in my program. I was on a single method, for example, or a single idea that I had. And I was blindly following it. And only at some point I realized that maybe this is the wrong way to go, because I forgot about the entire world outside. I only focused on a single thing. There is also a trap that you can fall into in medicine, which is called convenient diagnosis. And this is, for example, if you imagine walking on the street and you see a person who is lying on the bus stop, for example, on the bench, probably most people would assume that the person is drunk and they would just go away. And this is a very convenient excuse for not helping that person. But this doesn't necessarily mean that the person is only drunk. They may have some serious problem. And actually, by using this convenient excuse, this convenient diagnosis, you can see that you can skip something very important. An example in software development might be, for example, that your application is crashing. So you don't actually know what is happening, so you just decide to restart this application, and restarting the application every hour becomes your policy. And this is convenient because, well, you solve the problem. But you actually don't, because this is only a workaround. But instead of finding the root cause of your problem, you focused on some convenient explanation why this doesn't work. There is also another trap related to that, which is about relying on a very familiar tool. This is called golden hammer or a law of instrument. And this is a cognitive bias where you are using a tool, and if you have one tool, you solve all the problems that you have by using this single tool. So, for example, if you are using a particular framework, like Akka, for example, which is the actor system-based framework for asynchronous message processing, and then there is a lot of use cases in your application which actually can use Akka to be solved, and you are using Akka, you are solving this, it's perfectly fine. But then at some point, another problem appears, and even at first sight, it doesn't really seem like it should be solved with Akka. But, well, you already have this tool on board. You don't want to introduce any new library. Everyone knows Akka because you are using it, or it can be any other library. So you are trying to solve this new problem with the existing tool that you have at hand. And at some point, you might notice that it's actually counterintuitive, that you are doing a lot of workarounds just to be able to use this single tool to solve your problem. And that's not good, because if you fall in this golden hammer trap, even a screw like this in this slide seems to be a nail, and you are trying to work with it as if it was a nail, but it isn't. This problem should be approached in a different way. So when you're analyzing problems, when you are troubleshooting things in your daily job, you shouldn't really blindly follow a single path that you have taken. If you have a feeling that you might get stuck or maybe the solution lies somewhere else, this is high time you like stepped back, looked around, maybe asked your colleagues whether for help, for some other insights, and you should try to approach the problem from a different perspective, because you might have gotten into the situation where you have those blinders on your eyes, and actually the solution is lying somewhere else, but you are too focused on your intuition and on your approach. You should also be choosing the right tool for your job. So even if you've been using a library for a long time, you should actually think whether, if you have a new problem to solve, whether this library actually solves this. And you should avoid those convenient diagnoses. So if you have an issue, you should really struggle to find the root cause of the issue. So why this is really happening? Why in the example that I gave with the crashing application, if there is, for example, a memory leak and you need to restart your application every hour, you should really find where does this memory leak come from, and not end up with restarting the application every hour. This is a convenient excuse, but this doesn't solve the problem, actually. So this is a switch. This is a photo taken in a Polish hospital, so I will translate the things for you. So alarm at the top is probably very intuitive. It's like triggering an alarm. The letters at the bottom are for light. So one of the switches is for triggering an alarm. The second is for turning the light on. So please now think, what do you do when you enter your room in a familiar place, for example, at your home, and what do you do to turn off the light? Well, probably you don't approach the switch, like look which switch is for what. You just like put your hand somewhere there because you know where the switch is, and you just press it. So imagine what would happen if you like randomly pressed one of the two switches here. Another question is, if you use the wrong button here by just like blindly pressing this switch, is this your error? Is this the error that you made, or is this rather a system error because this was like poorly designed? And I would argue that this is the latter. So it's actually, well, it's not your fault that you did it like that, because this is like an obvious hole in the system, in the design that shouldn't be there. Because if it was designed correctly, a lot of like troublesome situations might be avoided. So this section is about avoiding some obvious holes like that. In many hospitals, doctors or nurses here who are distributing drugs are wearing vests like that. That clearly indicate that this person is focused on something very important, and you shouldn't interrupt them because this might have some serious consequences. So now you imagine something like that for software developers. For example, you have a vest that it says "Do not disturb. I'm deploying to production." Well, this probably wouldn't be a great idea, but still, this is about indicating situations where we need to focus and where we need to avoid distractions. So there are a lot of measures that we can take to be on the safer side in our daily lives as software developers. But the important thing is that one security layer is not enough, because if you only introduce like one or two security measures, they might not be enough. Why? Well, imagine that your security layer is a slice of cheese. Well, no security layer is perfect. So if you imagine the layer being this slice of cheese, it has holes, and the holes in this slice of cheese are the holes in your security layer. Well, because it's not perfect. So these holes in this slice of cheese represent some kinds of vulnerabilities in your security layers. Now, if you put a couple of cheese slices like that next to each other, and you imagine that you have some hazards flowing from the left to the right, then, well, it might happen that even if you have multiple security layers, that in some of them the holes align and then the hazard is passing through. But in most of the cases, the more layers you have, the smaller the probability is that a hazard would propagate through the very end. So this is why it is important to have multiple security layers that are independent. Of course, you need to find some compromise, like too much is also not a good idea, but this should be more than one, for sure. So let's now talk about a couple of examples what such security layers could be in your daily lives. One example is using read-only access whenever it's possible and whenever you don't need a write access to a database, for example. So if you think about the queries that you are executing against your production database, for example, just to check some data like whether a user is there or whether it has some certain properties, I would argue that in like 90% of the cases you don't need a right access to the database because you're only querying for information, and actually you should seldom be doing any manual changes, manual writes to the production database, unless you are migrating data or something like that. And then only if you specifically need right access to the database, you should have a dedicated way to connecting to the database for right purposes. But this shouldn't be the default. And there are a couple of ways how you can do it. It depends on the database. In a simple relational database, for example, you can have user privileges that say whether a user is allowed to write or not. In distributed databases, like we can take Mongo as an example, then Mongo has several nodes and only one of them is allowed to accept write requests. The others are only allowed to accept reads. So what you can do is to connect when you want to connect to your Mongo instance to retrieve some data, you can connect by default to the read-only instances and only connect to the master one when you actually need to write data. So the default behavior should be read-only. Another case is about distinguishing different environments that you are working on. So here is an example of using different colors for the tabs in your terminal, depending on which environment you are accessing. And you will probably guess that the red one is for production, the yellow is for some like staging environment, and the other ones are for dev environments where you should be able to do whatever you want. And this can even be automated somehow because you can tweak your shell to have the colors introduced in different places. This can be based on your SSH config, for example. So if you connect to a particular host, your either tab color or the command prompt changes to a different color, so that it clearly tells you that, hey, in this tab you are in production and you should be really careful about what you are doing. Another security layer that you can introduce is using switches like Dryrun to the commands you are executing. And this is especially important when your commands are touching a lot of stuff at once. So for example, you are syncing your file system to somewhere else, or you are doing, for example, a Kubernetes deployment with Helm. And then whenever your tool that you are using provides some kind of a dry run mode, you should be using that, because the dry run allows you to preview the changes that are going to be made. And only then, when you verify that the changes that are going to happen are correct, you should write the command without the dry run switch. And this might become specifically useful, for example, when you are copying or syncing a lot of files and you are using like tab completion in your shell. And then you are using some wildcards, and then accidentally for example, you don't fill the file name at the end, but you end up with only having a single directory. So then it may end up in a lot of files being deleted if you don't spot it. But if you use the dry run switch, then you will have a preview of what changes are going to be executed. You will see that, like the entire directory is going to be deleted, and this is not what you want. So use dry runs whenever you can. Let's now talk about naming things, especially when you are maintaining your code. So we know that there are three main challenges in IT. The first is naming things. The second is off-by-one errors. So imagine that you have your method find user by ID, the one here. This is perfectly fine, like there's nothing wrong with the code here. But imagine that there is a new requirement that whenever you find a user by ID, it should be activated. And then there is a developer who comes and implements it. They add some logic for activating the user, the finder method. Of course, this is not how this should be done, because the method is having some side effects, but it should actually only be fetching the user from the database. But it was implemented like that. It might be a crazy requirement, but the method name remains unchanged. And now imagine that you are using this API. You are you see what method your service offers. You can see that it offers a find user by ID method, so you won't assume any side effects here because of the name. Like probably not always you are looking at the actual implementation of the method which we are using. It may have some Java doc or another doc in another language that you are using, which also might not have been updated along with the change in the code. And now you end up with some side effects happening in your production environment, and you only notice them probably after some time, when this code was already deployed and when it was run, only because someone didn't update the method name. So like good method names are like this. It is one of the things that you know from the books like Clean Code, they should be descriptive, and they should also be kept descriptive whenever you update that method. So as you saw, we have a lot of holes, sometimes more obvious, sometimes less obvious in our daily routines, and we have the ways to prevent them. But in order to prevent them, we should be using more than one security layers in order to prevent the hazards from propagating, because the more security layers you have, the less the probability is that a hazard would actually propagate down to your system. And it's of course better to be safe and to introduce those layers than be sorry afterwards. So now I want to talk about one specific way about reducing the probability of errors. So what you see here is actually a checklist. The ABC here stands for airways, breathing, and circulation. So this is a checklist when you approach a person and you want to assess their state, like you have a casualty and you want to see what's happening. Here's another checklist that when you verify that the person is pretty much fine, you assess the further state, and this stands for symptoms, allergies, medications, past medical history, lunch, and events. So I would argue that it's much easier to memorize those two short words or phrases like ABC and sample, and then it's much easier to fetch from your memory what they actually mean especially when you are doing something under stress. And that's the reason why we should be using checklists at all, because when we are working under pressure, if you have a checklist for things you have to do, it minimizes the effort that your brain needs to make to actually perform all the tasks. Imagine going shopping without a shopping list. Well, it's perfectly doable, but it requires a bit more activity from your brain than if you just had a shopping list on your mobile or on a piece of paper, and then you just tick out the items that you already bought. If you don't have a checklist and you have a lot of stuff to buy, then you might end up with forgetting the most crucial thing for your dinner, for example, and then you need to go back, and it takes much more time. And also there are researches that show that people tend to omit the most obvious steps. So it's not like you are going to omit the most complex steps, the most difficult one in the set of actions that you are performing. You are usually going to omit the most basic ones, and then you would say how could I forget about it, because it was so obvious. But that's how it works. So where can checklists be useful in a software developer world? Well, for example, imagine that you are doing a first deployment to a new environment, specifically to a production one. So then there is a couple of steps to do, like you need to probably maybe turn off the old application, you need to deploy the new one, you might need to migrate some data. There is a sequence of steps that should be done. They should be done in order, and this lets you verify that you haven't forgotten about anything. I already spoke about migrating some critical data. So if it's a critical operation, it might also use a checklist, because once again, you need to do a specific sequence of operations for that operation to be successful. So what makes a good checklist? Well, first of all, it should be short or concise. So it should only contain the steps that are truly relevant to the process that you are performing. It should be descriptive enough for you to understand what needs to be done, but this shouldn't be a book, so this should be concise, so short and telling what actually needs to be done. It should be verified in a real situation, so you can think of it a bit like about backups. So a backup is as good as it was proven to be restorable. So if you have a backup of your computer, for example, but you never tried to restore it, you actually don't know much about the backup. It's like a Schrödinger's backup, because you don't know if it works or not before you restored it at least once. And the same applies to the checklist. So, for example, if you write a checklist for migration of data, and then the first time you execute it is actually while doing the migration in production, it may turn out that some of the steps don't relate to each other, or that you swapped the order, and you should actually have done something first, but you are already in the process, and it might be too late to roll back. So you should do a dry run that we already spoke about. You should verify that this sequence of steps actually works. A checklist should also be used consciously. So whenever you perform a step from your checklist, you should have a way to verify that it was actually performed. So you may imagine, for example, doing important things in pairs, even remotely. So when you are doing deployment to production, you have prepared your checklist, and then you take your colleague, you sit together, and you said that you are going to do this one. They confirm, yeah, okay, that's fine, we are doing that. And by this, you can confirm that all the steps were actually performed. There is a very specific implementation of this on Japanese railways, and this is called point and call. So if you have a train operator in Japan, whenever they, for example, see a sign with a speed limit, they need to point at this sign and, for example, point at it and say speed limit 60 kilometers per hour. And this may look funny. There are videos on YouTube that show that. And when you watch them, they are actually funny. But it turns out that they have significantly reduced the number of accidents that were happening on the railways. So although some of these activities may seem funny, the sole step of like confirming the action you are doing and confirming that you are aware of the fact that you are doing something can save you a lot. So your brains can do you tricks, and no brain is perfect. You are never going to remember about anything. So the checklists are there to help you, but maybe not to save you, but at least to help you. So we've talked about ways to prevent errors, but what should we do when an error actually happens? Because like to err is human, and errors are unavoidable. So they will always be with us. And now, in this session, we are comparing emergency medicine to IT. Of course, the consequences of errors in medicine might be much more like complex or critical than in IT, because in medicine, basically, someone might die. In IT, well, like unless you are developing some life-saving software, this is probably only about the money. It might be about a huge amount of money, but it's still only money. But although the fields are different and like the consequences might be different, the approaches and techniques to deal with errors are pretty similar. And the first technique is called, in medicine or in military, it's called debriefing. In our world, we call it a retrospective, when you are doing Scrum, for example. And retrospective or debriefing is basically about looking back when you finished like a complex task or something difficult, and seeing what went wrong, what went fine. And this is not about pointing fingers at people and saying like you broke everything, it was your fault. It's rather about assessing the process. So what were the good parts, what were the bad parts, and what we can improve in the future. And this should make you think how errors can be prevented. It's okay to make mistakes, but you shouldn't be making the same mistake twice. And retrospectives are a tool to look at it and to avoid doing the same thing wrong another time. One thing that I want to stress here is that remote work that probably most of us are used to by now is not an excuse for doing retrospectives. The screenshot you can see here, and is blurred on purpose, so it's not the like projector's fault that you can see it. This is a screenshot from an actual retrospective that we did at Software Mill. There were like, I think 60 people taking part in this remotely, and it went amazingly fine. So we had one person moderated. We had different categories, and we were written down all the stuff, and it was surprisingly productive. Like we didn't expect much from like 60 people discussing stuff on Zoom, but it went surprisingly fine. And this retrospective here has a lot of dimensions. Like you can see the main ones, which are the thumbs up and thumbs down, but you have also some categories related to areas at which we work. But this doesn't necessarily need to look like that. So you can start very simple. You can start with a simple table where you have a plus column and a minus column, and then you just write down stuff. You write down things that you want to talk about. And again, this is mainly about honesty and by not blaming people directly. Like you should describe the process, describe the facts, what went wrong, not blame other people. Of course, in some situations, well, things would go wrong. And you should plan for it, because you cannot avoid that. Like sooner or later, it is going to happen. So it's very good to have like a plan B for any action that you are performing, or an emergency plan. For example, this could be about rolling back to a previous version of your application if you have deployed something and then it turns out that you accidentally deployed an erroneous application. In one of the projects I was working in, we had a situation where we deployed a new version to production, and it was on Friday before Easter. So, like, of course, what could go wrong when you deploy on Friday, especially before Easter? And then on Saturday, we got a notice from our customer. They were in Australia, so there were those time zone differences as well. And we learned that something is not working. So we said, well, okay, we will roll back to the previous version, and then when we come back on Tuesday, then we'll look at what actually happened. But it turned out that we didn't have a way to quickly roll back to the previous version. So we started our CI process, which was running some very long integration tests. To make things worse, the integration tests were failing randomly, so we didn't succeed to build the old image at like for the first time we run our CI server. It took us like 2 or 3 runs to be able to build the old image actually and to restore it. So an action that should probably take like a couple of minutes, because you should have the previous artifact somewhere and you should just be able to restore it. It took us like 2 hours and it was too long. So actually the first thing we did when we came back after Easter was not fixing the bug, but creating a proper pipeline for quickly restoring previous versions. So plan for failures, because you are never going to be able to avoid them. Imagine a conversation where a developer comes to their manager and they say that, hey, manager, we have a problem. And then the manager says, well, remember, there are no such things as problems, there are only opportunities. And then the developer says, okay, then we have a DDoS opportunity in production. Well, funny as it may seem, this still passes an important message, because this means that whenever something goes wrong in production, well, it has already happened, and you can do damage control so that like you avoid further damages. But you should treat this as an opportunity to learn and to avoid similar situations in the future. And an organized way to learn from failures is to prepare or write postmortems after something goes wrong. And now again, when we relate this to medicine, in medicine, postmortem means something very serious because it means someone has died. In IT, it's not that serious because it just means that like something went wrong in production, but it might actually be not that bad. So what makes a good postmortem? Well, first of all, you should have a like chronology of things that happened. So you should write down the events to know what happened. Ideally, this would be with timestamps, so you can like restore all the history and all the actions that were taken. Then you should describe the actual problem and what the consequences were. So what was broken actually, like what did your client lose, for example, and what effect did it have? Of course, the most important part is how it was solved, how the issue was solved. But actually, this is not the most important one. The most important one is the next one, which is how to avoid a similar situation in the future. So like the lessons learned from this situation. And a good postmortem needs to end up with some concrete action points. So some concrete actions to do assigned to concrete people. So it's not like you described what happened, you described how you solved it, you more or less know how to prevent this from happening in the future. But there are usually some steps to take, and this should be addressed for this to be effective, they should be addressed by concrete people. So it shouldn't be like left dangling that someone would do this at some point in the future. This should be concrete people doing concrete things. So the errors or mistakes are always going to be with us, and you shouldn't really be afraid of making them. Actually, what you should be doing is building a safety culture, and the safety culture is a like working culture where people are not afraid to make mistakes, because the mistakes are always going to happen. In yet another client I was working on, they explicitly called errors that happened in production learning opportunities. So they kept telling us that in production we don't have like errors, we have learning opportunities, and it's okay that something goes wrong. We should just be prepared to, for example, roll back quickly or to deploy FX quickly. So summing up what we have gone through today, first of all, you should be avoiding cargo cults. So this means that you should be asking questions, why you are doing stuff. And you should avoid blindly following other people and using technologies or tools only because other people do it. It's perfectly fine to use the tools, but this should be an informed decision when you choose to use a tool or not. You should trust that you are good developers, because you are, but you should also have a way to prove or verify that the software you are written is working correctly, that it is performing all the stuff that it should be performing, and it's like serving the business requirements. You should avoid focusing too much on single things, and you should avoid having those blinders on your eyes. So whenever you have a feeling that like you followed a path too deeply, and probably this might not have been the right path, you should take your time to take a step back, look around, ask people around whether maybe they have another idea to solve this. You should think about adding security layers to your processes, to your applications, because the more security layers you have, the less the probability is that some hazards are going to slip through the security layers. And you need to find a compromise between like the having too few security layers and too much of them, because neither is good. So you should learn something in the middle, but this is very specific to the situation you have. You should remember that our brains are tricky, and we have a tendency to omit some very obvious stuff when we are specifically when we're working under pressure. So this is where checklists can help you. So you can write down the sequence of steps that you need to take, tick and confirm that you have done something. And this might seem trivial, but would help you a lot avoid a lot of errors. And last but not least, you should focus on building a safety culture in your working environment. So a culture where people are allowed to make mistakes and where actually it's not bad that someone has made a mistake. It should be a learning opportunity for everyone. In one of the companies I worked for, there was an architect, I think, who told us that like whenever a developer makes a mistake and that is deployed to production, they should be fixing them in their free time. And in my opinion, this is inherently wrong, because like this like punishes making mistakes, and this like it violates the assumption that mistakes are always going to be with us. So what I prefer is a company culture where you can make mistakes, but you should have a way to learn from them. And before I finish this talk, well, I'm not allowed to give you any medical and first aid training, because I'm not a paramedic. But I still want to pass two important messages. So, first of all, first aid is mostly about noticing that someone might need your help. So, whenever you see someone somewhere who might need help and you are not sure, just approach them and ask. So even if you don't know how to help, it might be enough just to call the emergency number. But it's important to be watchful and to do something, because the problem is that in most of the cases people just ignore it, because, for example, they have their convenient excuse that, well, the person is drunk, I'm not going to approach. You can ask. If they are drunk, they will tell you probably, or you will notice that. Another important message is that the statistics say that if you are going to need to help anyone and to give first aid to anyone, this would probably going to be someone of your closest ones. So this is a very good reason to take a first aid course whenever you have the possibility, because if you are going to help anyone, this would probably be the person that is really important to you. That's all I had for today. Thanks for being here and remotely, and thank you for your attention. If you have any questions, I'm happy to take them.
Thank you very much, Jacek. I'm talking from a cloud, through cloud, won't go down. Is there any questions for Jacek? Yes, we have one. Let's take it from here. Yes,
Yep.
Let's just shout out loud.
I'll try to see you. Sorry. Yeah, okay. Okay. Okay, so I was asked to repeat the question. So the question was about what, in my opinion, would be a good approach to debug code, to find problems in order to like not to miss the gorillas. So in order to be able to spot different things, even if they are like somewhere else. Well, I think one of the answers would be to discuss this with someone else. So like for sure, when you start to debug your code, you start doing it yourself. But then, well, to me, it happened a couple of times that I was not sure, but I had a feeling that I'm like following the wrong path. And then I just discussed this with my colleague. And actually, they had a completely different approach to that. Like they opened my eyes, because my colleague told me that, hey, like maybe the problem is lying completely elsewhere, and maybe like you focused on the wrong thing, or you chose a convenient explanation because this was easy for you. So the only advice that comes to my mind at this point is to discuss that with other people. This is similar to like doing pair programming or doing code reviews. So take input from other people, because even if you are working on the same code base, they can still have a completely different view of the code. For example, they might have a different mental model of your code, of the flows in your code. And if you just ask them, they might be able to help you, because they'll give you like another pair of eyes, and that's it.
Thank you. Are there any more questions? So thank you very much, Jacek, and see everyone at the party today at 9. A round of applause for Jacek.
Thank you.